The next step to this problem is finding out the short circuit current, and I wrote down for reference this information here, the open circuit voltage. Of course, ZTH is going to equal the open circuit voltage divided by the closed circuit current. Okay, so we're going to do loop analysis here, and we're going to have I and ISC. So we can write down the loop equations. So we have the negative Vx prime, Vx double prime here, I1, so the voltage is going to be more positive on this end than this end, and since we're going in the opposite direction, yeah, you get a positive value. The way I usually look at it is, okay, this would be positive, so this would be a flip sign here, and then this would be a voltage drop across here, so this would be a negative sign, and you'd have this, the difference between the two currents, 2 ohms, and this would be a negative sign also, and then finally a positive sign here. Well, anyway, they got everything negative. It's just the way I learn things. I learn things differently. And that's supposed to be 0 degrees right here. Okay, equals 0. Rearranging the equation, we got this. Next equation, the controlling variable Vx double prime is going to be given by this. Now, does this make sense? This potential for I1, this is more positive than this, so it'd be a negative in the I, excuse me, not I1, I. And if the current is going the opposite direction, it'd be positive. So this makes sense. It still makes sense. Substituting, rearranging 2 equations and 2 unknowns, and we can put that in new octave. Okay, coming on back. So I forgot to talk about this equation a little bit. You got 4 volts, and then I like to think of it as the current going this way. So I have an I prime going on, which will be equal to negative ISC, the way the authors defined it. So I'd have the positive 4, and then I'd have a negative I prime times 2, and then I have to put in another negative to get this term right here. And then the ISC and the I would both be in the same direction. It's a so I'd have a positive I prime plus I times 2, and since no, I'm sorry, it'd be a negative. It's a voltage drop. I'm thinking voltage drop. If I used I prime, we'd have a voltage drop going this way, and the current would be going this way. So it'd be a negative 2 I plus I prime. Well, I prime is negative ISC, so we get this equation. So everything works out, no matter which way you think about it. I like to think of voltage drops. That's just the way I learned it. You're going up in voltage, then you're going downhill in the other parts of the circuit. Either way you look at it, you wind up with these equations. And I plug them into new octave, which is pretty good for solving this stuff. working with complex numbers right here. So I have a matrix 4 plus 4j, and negative 4 here, 4 for the voltage, negative 2 here, 2 minus 2j here equals negative 4. And then I grab my answer, and this is what I get. And so the first term, the I would be this right here, would be negative 1, negative j, and the ISC would be negative 1, negative 2j. So back to here. And they go through and solving it. Let's see. ISC is negative 1 minus 2j. Good. Root 5, 2 negative signs, third quadrant again. So we got this going on. Just be careful about that a little bit. Make sure you're in the right quadrant. And VOC, and then now we can get the final answer. We get ZTH. Remember, ZTH is going to be this. VOC over ISC. And then you can, and of course RTH is the real part of ZTH. Okay? I'm going to pause just a second, go back to new octave a second, just double check answers. Here's the new octave output here. You'll see ISC is 1 minus 2i, or 2j, excuse me, which will equal the square root of 5. The magnitude is the square root of 5. Angle 116.57. If you use MATLAB or new octave, you will notice that it takes care of the fact it's in third quadrant, angle of this complex number. That's kind of cool about that. VOC, 3 minus j, leaving it in complex number notation, doing the division in new octave, 1 minus j is going to be VOC. And let's go over here. VOC, 1 says minus 3 minus j. Let me go take a look at that. Make sure I got that right. Oh yeah, minus 3 minus j. New octave says the impedance is 1 minus j. Excuse me, the impedance is 1 minus j. Next step. So ZTH 1 minus j. The optimum is 1 plus j. Right there. And then finally, RTH is 1. VOC squared is going to be 10. So that's going to be 10 over 8, or 1.25 watts. Okay, now your turn. This isn't even a dependent circuit. What does the load impedance have to be, and what is the power to that load? So I'm going to stop this video here, skip over other similar questions, and go on to the next topic in the next video.